All right, Honors Algebra 2. Here we are for your 5558 game plan video number 2. We are starting on page 8 in that game plan. This page only has 3 questions. Number 2, that is, given that x equals 2 is a solution to that polynomial, x cubed plus 3x squared minus 4x minus 12 equals 0. Find the other 2 solutions. So I have told you that, yes, x equals 2 is a solution, and also x minus 2 is a factor. So I am basically telling you to divide by x minus 2, thus putting 2 in the cubby, because remember, you take what you're dividing by and set it equal to 0. So they've already given me that. That goes in the cubby, and I want to know what is left over. So I got 1x to the third plus 3x squared minus 4x minus 12. I put a 1 here for 1x to the third, 3 for 3x squared, negative 4 for negative 4x, and negative 12 for negative 12x to 0, or the constant. We always bring that first term down 1, because I'm really doing 1x to the third divided by a single x. Bring 1 down, and then for synthetic division, the 2 operations I do multiply and add. Take the cubby number 2, multiply it by that number below. 2 times 1 is 3. Then I add the columns. 3 plus 2 is 5. 2 times 5 is 10. Add the columns. 6. 2 times 6 is 12. Add the numbers in the column. Now, I should get 0 because I have told you that x equals 2 is a solution and x minus 2 is a factor. So we should always get 0 here as a remainder. If we don't, there's an issue. So what do 1, 5, and 6 mean? I started with x to the third. Then I did, in fact, divide by a power of x. So I'm going to subtract 1 from that initial exponent, 3. This would be 1x squared, followed by 5x. Keep dropping a power, followed by the constant 6. Now, I want the other 2 solutions, so I immediately set this equal to 0, and I hope that it can factor, and it can. What 2 numbers multiply to 6 and add to 5? That'd be 3 and 2, both positive. All right. X plus 3, x plus 2 would then equal 0. Cover-up method tells me x plus 3 equals 0, x plus 2 equals 0. I solve those very easy equations, and I get my other 2 solutions of negative 3 and negative 2. All right, so these are nice because you know that the remainder has to be 0, so you can get a little guidance as to whether or not you got started correctly. So on number 3, given that x equals negative 3 is a solution to that, find the other 2 solutions. So again, negative 3 goes in the cubby. They've already told me that x plus 3 is a factor, and they already set it equal to 0 for me. I put a 1 for 1x to the third, a 2 for 2x squared, a negative 5 for negative 5x, and a negative 6. No exponent was skipped. Again, here's the 1. 1x to the third, 2x squared, negative 5x, negative 6. I kind of showed the work here. So what did I do? I brought the 1 down, then did negative 3 times 1. That's a negative 3. Then I added the column. Let's get negative 1. I then took negative 3 times negative 1. Gives me 3. Add that column, negative 2. I then took negative 3 times negative 2. Got 6. Add them up. I did get a remainder of 0. I started with x to the third. I divided by a power of x, so that 1 is going to stand for 1x squared, 1 power less, minus 1x minus 2. I immediately set that equal to 0. I'm looking for the 2 other roots. What multiplies to 2 and differs by 1? That'd be 2 and 1. The middle term's negative, so the bigger factor, 2, has to be negative. X minus 2 times x plus 1 is 0. Cover a method. X minus 2 is 0. X plus 1 is 0. Solve those 2 easy equations. All right, this is a pretty big question for us, this upcoming, the second quiz of the chapter. All right, 5-7 here, what we know from before. So these are your 5-7 notes. Section 5.7 corresponds exactly to 5-7 in the textbook that we're sort of using. So this is just a review. What multiplies to 12 adds to 7, positive 4, positive 3. Then I get my 2 solutions. Okay, you can try all of these beforehand. Then 4, what multiplies to 28 differs by 3. That'd be 7 and 4. Middle term's negative, so 7, the bigger factor, is negative. 4 would be positive. X equals 7, x equals negative 4. Again, you need a negative constants, which is the product, and a negative sum. All right, so 5 and 6, factor by grouping. When you have 4 terms here, you're going to try to group the first 2 together and the second 2 together. If not, you have to rearrange in some fashion. So grouping these 2 together, they both have x to the second in common. All right, I can take an x squared away. When I do that, I'm dividing both the terms by x squared. So this had 3 in an exponent. I took 2 away. I'm left with a single x plus. It had x to the second, and you took it away, so it's just plus 8 now. Always bring down the sign in the middle, whether it's positive or negative. These 2 terms don't have an x in common, but they're both multiples of 5. So factor or divide a 5 out. 5x divided by 5 is x, plus 40 divided by 5 is 8. Notice how these 2 parentheses have the same 2 terms. That should always happen. If not, it does not factor, or we made a boo-boo. So x plus 8 goes together in 1 parentheses, and these 2 on the outside then form their own parentheses. Okay, so notice how x squared will multiply with x and 8, like it's doing there. And notice how the 5 will also multiply with x and 8 if I were to FOIL it, like it is there. Okay, we're just going in reverse order. And it's been factored. On 6, the same deal here. We're going to put these first 2 terms together. They both have x to the second in common. We factor it out. X to the third, we took away 2 in the exponent, so you're left with x plus 7x squared. If I take away the x squared, I'm just left with 7. Now be careful here. The sign in the middle is a minus, so you're factoring out a negative. Negative 9x squared divided by a negative 9 is a positive x. A negative 63 divided by a negative 9 is a positive 7, and that gives me x plus 7 twice, which is good. They both go in that ordered pair. They can go in the first one. The order doesn't matter. And the x squared minus 9 goes in the other ordered pair. Now, to get the full credit on this in a quiz or a test, x squared minus 9 can factor more. What multiplies to 9 and differs by 0? There's no middle term there. That is the difference of 2 perfect squares, x plus 3, x minus 3. All right, so this would give you the full credits. Then number 7, that is a review from chapter 4. Write the equation of a quadratic with roots of negative 3 and 5. So I'm telling you that x equals negative 3 and x equals 5. Move it over. So then x plus 3 would have to equal 0 to give you x equals negative 3, and x minus 5 would have to equal 0 to give you x equals 5. We can get rid of that equals sign. And we can just first, outer, inner, last. Again, the arrows mean multiplication. X times x is x squared. X times a negative 5 is negative 5x. 3 times x is 3x. 3 times a negative 5 is a negative 15. Combine like terms to get x squared minus 2x minus 15. That is all of the work there on page 9 we'll talk about in this video. Other ones we do in class. So kind of have a potpourri here of solving any sort of polynomial on page 10. So we just got to look to see what's going on here. So first off, all of these terms have at least an x, a single x. So I'm going to factor out the x, which means I'm going to take 1 away from the exponent in all these terms. All right, that's x to the third. It's now x squared. Plus, it was x squared. It's now x. Plus 32x now becomes 32 because I took its x away. So this looks like something that can factor. What multiplies to 32 and adds to 12? This is now easy factoring. 8 and 4. So now I have x times x plus 8 times x plus 4 equals 0. I do the cover-up method 3 times. That's a very easy answer. We can see there x equals 0. Then I have x plus 8 equals 0. Then I have x plus 4 equals 0. And that's how I get my 3 solutions. All right. That one is very, very similar to number 6, which we'll try in class. Let's take a look at number 4. Anytime you don't have a middle term, it's x to some power, mostly x squared, and a constant, we need to see, is this a difference of 2 perfect squares? And it is. Is there any number that multiplies to 81 and differs by 0? There's no middle term, and it's positive 9 and negative 9. So I wouldn't say x plus 9, x minus 9, because that's going to give me x squared minus 81, and this is close. Instead, it'd be x squared plus 9, x squared minus 9. X squared times x squared gives me x to the 4th. 9x squared minus 9x squared cancel out the middle terms. All right, so it factors to be x squared plus 9, x squared minus 9 equals 0. I set x squared plus 9 equal to 0, and I subtract 9 from both sides. I said x squared minus 9 equal to 0, and I add 9 to both sides. I'm left with that. Let's take the square root of both sides. Don't forget about the plus or minus. When you take the square root of a negative, immediately take the I out. Plus or minus I root 9. The square root of 9 is 3, so that's how I get my first 2 solutions. Positive 3i, negative 3i. Now this next one, the square root of 9 is 3. Remember, you are squaring some number to get 9. You can square both 3 and negative 3. That's why I always attach the plus or minus. All right? 4 solutions there. X is raised to the 4th power. And then the last kind of example here would be number 5, which looks just like number 4. So they all have an x in common, just like they did in 1. I factor out the x that they all have in common. And when I take 1 away from all of their exponents, I have x to the 4th minus 8x squared plus 16. So this is kind of like number 2. And then I'm going to ask what multiplies to 16 and adds to a negative 8. And those numbers would be negative 4, negative 4. Negative 4 times negative 4 is 16. Negative 4 plus negative 4 is a negative 8. So instead of being x minus 4, it's going to be x squared minus 4 times x squared minus 4. Again, x squared times x squared is x to the 4th. Cover-up method gives me x equals 0, and then x squared minus 4 equals 0 twice. I don't need to write that twice. Simple first solution of x equals 0. Then I set x squared minus 4 equal to 0. And I take the square root of 4, plus or minus root 4. Again, positive 2 and negative 2 squared give you 4. So it just has 3 distinct answers there, even though it could have up to 5. Highest power tells you how many answers you could have. All right, and we are on now page 11. This is the hashtag game time section, which is mostly on your own. Let's take a look at number 9 here. Going to factor by grouping. 4 terms mean you're definitely going to factor by grouping. Look at these first terms here. They both have at least x to the 2nd, so factor out x to the 2nd. X to the 3rd divided by x to the 2nd gives you x. You had 3 x's, you took 1 away, you left with 1. Plus, you had 2 x's, you took them both away, so you're just left with that constant 6. Always bring down the sign in the middle, so it's a plus. These 2 terms are multiples of 5, so take the 5 out. 5x divided by 5 is x, plus 30 divided by 5 is 6. Notice you have x plus 6 twice, so put that together in a single parentheses right there. And then these guys get grouped together, x squared plus 5. All right, so x squared plus 5 times x plus 6 is 0. I'm going to set x squared plus 5 equal to 0. I'm going to subtract 5 from both sides. I get x squared as a negative 5. I'm going to set x plus 6 equal to 0. I'm going to subtract 6 from both sides. That's my first answer, my 1 real root. Because when I take the square root, don't forget plus or minus of a negative 5, the I has to come out. X equals plus or minus I root 5. Speaking of answers with a bunch of i's, let's take a look at number 10. All those terms have an x in common, so I'm going to factor out the x. When I factor out an x, all those terms lose a power of x. 5 becomes 4, 3 becomes 2, and x to the first just becomes, or 10x to the first just becomes 10. And again, I have 3 terms here. I've got a middle term, I've got a constant. I always need to think about easy factoring. That's from Algebra 1. That says what multiplies to 10 and adds to 7, 5, and 2. X is on the outside. That's the first very easy answer to get. X equals 0 right there. Then I have x squared plus 5 equals 0. Then I have x squared plus 2 equals 0. So when I had x squared plus 5 equals 0, I subtract 5 from both sides. I get x squared equals negative 5. And when I had x squared plus 2 equals 0, I subtract 2 from both sides. Get x squared equals a negative 2. All right. Can take the square root of both sides. Don't forget about plus or minus. Anytime I'm taking the square root of a negative, that's the definition of an imaginary number. Take the I out. So plus or minus I root 5. Root 5 doesn't break down. It's irrational. It's a decimal. All right. Then plus or minus square root of negative 2. Take the I out. So it'd be plus or minus I root 2. Those are my other two solutions. So I technically have 5 solutions. 1, 2, 3, 4, 5. On number 11 here. 3 terms again, they all have an x. Factor out the x, every term loses a power of x, so 3 becomes 2, 2 becomes 1, negative 30x just becomes minus 30. Again, a lot of easy factoring in this chapter. What multiplies to 30 and differs by 1? Two numbers that multiply to 30 and differ by 1 would be 6 and 5. Middle term is negative, so the bigger factor 6 is negative, 5 would be positive. Negative 6 plus 5 is a negative 1. Negative 6 times 5 is a negative 30. And that's what we think about when we're doing easy factoring. X is 0. X minus 6 is 0. X plus 5 is 0. That's how I get my 3 solutions. As we finish here, let's take a look at 14. Getting close. So the directions, this is page 12 here. Write a polynomial function of least degree that have the given zeros. Least degree, because technically, I mean, you can have it. We've seen this before, where you had plus or minus root 2 different times. So we're saying you get negative 3 as an answer once. You get 2 as an answer once. You get 3 as an answer once, not 2 times or 3 times or whatever. So I'm telling you that x equals negative 3. I'm telling you that x equals 2, and I'm telling you that x equals 3. We should start it that way. So in the warm-up to section 5.7, you kind of did this question, only we just have one more factor. I'm going to move the negative 3 over. I'm going to move the 2 over. And I'm going to move the 3 over. So if x equals negative 3, then x plus 3 would be the factor. If x equals 2, then x minus 2 would be the factor. If x equals 3, then x minus 3 would be the factor. Well, a little bit more, a few more steps than 4, but I'm going to take these first 2 binomials, and I'm going to multiply or FOIL them. X squared minus 2x plus 3x minus 6. And that breaks down to give you x squared plus x minus 6. And then I'm going to bring down this extra x minus 3. And like I had in the first game plan of the chapter, I'm just going to distribute. So, you know, x squared times x is x to the third minus 3x squared plus x squared minus 3x, too many arrows here, minus 6x, and negative times a negative is a plus 18. Then I just combined like terms. All right. Not really too many issues on 13 through 15. It's where we get to 16 with the i's. So x equals negative 2, that's a fact. X equals 3. And then, folks, every single time we've gotten an answer involving I, we've always had plus or minus something with I. So if 3i is an answer, then its conjugate, negative 3i, is also an answer. We have not solved a polynomial or quadratic and gotten just a single answer with I. It's always been like plus or minus 2i, plus or minus I root 2, plus or minus I root 5. So if I tell you that 3i is an answer, negative 3i is also an answer. So here's what I recommend, because we don't want to multiply too much with I. So if x equals 3i and x equals negative 3i, here's how we should handle it. Do x times x, that's x squared. Do 3 times negative 3. If x equals 3i and x equals negative 3i, then x squared, x times x, would have to equal 3 times -3, -9. Don't believe me? Take the square root of both sides. You get plus or minus square root of -9, which is plus or minus 3i, which is what you have here. Okay, so simply do x times x, and then multiply those two numbers together. X squared would have to equal -9. Move the -9 over. X squared plus 9 would be a factor, while x plus 2 would be the other factor. If x equals -2, then x plus 2 is the factor. And now I just FOIL. First, x times x squared, x times 9, 2 times x squared, 2 times 9. And I just rearrange it. I want to write in standard form, highest power to lowest power. So working with the i's is actually not that bad, and especially on 18. And if I tell you that 0 is an answer and 4i is an answer, then -4i is also an answer. That's what you got to remember with I. If I give you one of them, I've really given you the second answer involving I. So x equals 0, got it. If x equals 4i and x equals -4i, I'm going to take x times x. That gives me x squared. X squared would have to equal 4 times -4, which is a -16. So again, if x equals plus or minus 4i, x squared would have to equal -16. 4 times -4. Let's take that -16. I'm going to move it over. If x squared equals -16, then x plus 16 would have been in that parentheses. Folks, if x equals 0, if I move 0 over, I'm not going to write x minus 0 or x plus 0. I'm just going to write x. All right, it would just be x. You would have this situation. Again, I can get rid of the equal sign. I just distribute. It'd be x to the third plus 16x is my pretty simple equation. All right. So here we are in the last section, section 5.8. What we know from before, so it's just asking you roots. Well, roots are the same things as solutions, as zeros. So if I ask you what are the roots, I'm just saying, hey, solve this. So what you'll get a lot in this section is it'll say f of x equals blank and find its roots. So you simply need to say 0 equals x squared plus x minus 56. It's really just a new way of asking you the same thing. So what multiplies 56 differs by 1. 8 and 7, the middle term is positive, so the bigger factor 8 is positive. And then 7 is negative. X plus 8 equals 0. X minus 7 equals 0 gives you those two answers. So same thing on 4. If I want you to find the roots of that, then 0 equals, again, a 0 is the same thing as x-intercept when it crosses the x-axis when y is 0. Well, multiplies to 30 and adds to a -11, a -6, and a -5. X minus 6 is 0. X minus 5 is 0. All right, here we are, number 5. Factor, what multiplies 15 adds to 8, 5 and 3. Instead of saying x plus 5, x plus 3, if I have x to the fourth, it's got to be x squared and x squared. Again, you can always FOIL it out to check yourself. 63, well, multiplies to 63 and adds to a -16, a -9, and a -7. And again, instead of x times x, it's got to be x squared times x squared. That gives you x to the fourth. X squared minus 9, x squared minus 7. Now we're solving. So set that equal to 0. Set that equal to 0. Add 9 and add 7 over to the other side. Take the square root. Don't forget about plus or minus. Take the square root. Don't forget about plus or minus. On page 14, again, this is nothing new. Find all the rational zeros of each function. Now, technically, if it wants rational, it doesn't want, just get rid of that. Find all the zeros. It wouldn't want any answers with I. But what we're going to do is we're going to take this right here, x squared plus 8x minus 32, and we're going to set it equal to 0. All right, that's the only difference this section. Well, multiplies 32, it differs by 8. That would be 8 and 4. The middle term is positive, so the bigger factor 8's got to be positive. Cover up method, x squared plus 8 is 0. Subtract 8 from both sides. Cover up method, x squared minus 4 is 0. Add 4 to both sides. We're going to take the square roots of -8, square root of 4. Don't forget about the plus or minus on the outside. You get I root 8 plus or minus I root 8 plus or minus 4. Here we are on number 4. Going to solve by factoring by grouping, just like the previous section. Only this time I'm just going to say 0 equals. It's just missing the 0 equals part. These two terms have an x squared in common, so I factor out the x squared. 4x to them. I'm going to subtract 2 from that exponent, so 4x. Plus, x squared divided by x squared is not 0, but it's 1. Bring down that plus in the middle. These two terms have a 4. They're multiples of 4. They have a 4 in common. 16 divided by 4, 4x. Plus 4 divided by 4, 1. 4x plus 1, 4x plus 1. These same two terms, they to go together in one parenthesis. And then the x squared plus 4 go together in the other parenthesis. So it's been factored. Cover-up method tells me 4x plus 1 equals 0. That's how I get x as a negative 1/4. Cover-up method tells me that x squared plus 4 is 0. I subtract 4 from both sides. I take the square root of a negative 4. That's plus or minus I root 4. The square root of 4 is 2. That's how I get plus or minus 2i. And the last few to conclude this game time. Find all, again, zeros, because then we wouldn't have imaginary ones. Or like just root 5, so just find all zeros. All right, so I say 0 equals, these two have an x squared in common. Factor out the x squared, so it's going to be 5x to the first. It loses 2 in the exponent. Minus, take away its x squared, just left with minus 3. Bring down the plus. 25x minus 15. They're both multiples of 5. Divide them both by 5. 25x divided by 5 is 5x. Minus 15 divided by 5 is 3. 5x minus 3, 5x minus 3. You see that twice. That's good. They go in one parenthesis. Just going backwards here. X squared plus 5 go in the other parenthesis. Cover-up method tells you x squared plus 5 is 0. 5x minus 3 is 0. That's how we solve both. All right. Make sure you have that. We're going to finish this off. Number 11. So you have 3 terms here. We have a constant, too, so we need to try to think about easy factoring. What multiplies to 63 differs by 2. 9 and 7. Middle term's negative, so the bigger factor 9 is negative, while the other factor is positive. X squared minus 9, x squared plus 7. Cover-up method, x squared minus 9 is 0. Add 9 to both sides. X squared plus 7 is 0. Subtract 7 from both sides. All right, take the square root, both. Plus or minus I root 7, plus or minus the square root of 9, which is plus or minus 3. All right, 12 is very much like 8. These two have an x squared in common. Factor it out. So you're going to be left with 2x minus, take away its x squared, 3. This time you have a negative in the middle, so you're going to factor out a negative, bring down the same sign. These are both multiples of 7. You're going to factor out a negative 7. Negative 14x divided by negative 7 is the 2x that you need. You need a positive 2x. It has to match up exactly. Positive 21 divided by negative 7 is a negative 3, and that's what you need. 2x minus 3 twice goes together in one parenthesis. X squared minus 7 goes together in the other parenthesis. Just kind of working backwards here. All right, set x squared minus 7 equal to 0. Add 7 to both sides. Set 2x minus 3 equal to 0. Add 3 to both sides. Divide by 2. Take the square root, plus or minus root 7. That finishes up your game plan video, and this is Jack Math video signing out.